Hi, continuing from where we left off, let's do the next question, the third question in the exercise. Verify whether the following are zeros of the polynomial indicated against them. So the first question is P of x equals 3x plus 1, x equals minus 1 by 3. So when is it a zero of the polynomial? If I were to substitute this value here in the polynomial, if the whole value becomes 0, then this particular value of x is a zero of the polynomial. Let me show you. So P of minus 1 by 3 is equal to 3 into minus 1 by 3 plus 1. So the 3 and the 3 cancel and you get minus 1 plus 1, which becomes 0. So the whole polynomial becomes 0 when x is equal to minus 1 by 3. Therefore, x is equal to minus 1 by 3 is a zero of the polynomial. So you should write yes, it is a zero of the polynomial. Let's go to the next one. The next one is P of x equals 5x minus pi and x is equal to 4 by 5. So let us substitute it. P of 4 by 5 equals 5 into 4 by 5 minus pi. So this is 20 by 5, and if I were to take the value of pi as 22 by 7, I still find that this value is not equal to 0. Therefore, x is equal to 4 by 5 is not a zero of the polynomial. Going on to the next question. So the answer is no for this particular one. Now the third one is P of x is x squared minus 1, and there have been two values given, x is equal to 1 and minus 1. So let's try both. So P of 1 equals 1 squared minus 1, which is equal to 0. 1 squared is 1, so 1 minus 1 is 0. So P of minus 1, this is minus 1 whole squared minus 1. Minus 1 the whole squared is 1. So 1 minus 1 equals 0. Therefore, both 1 and minus 1 are zeros of the polynomial. So both are zeros. Now the next question. P, this is the third one. The fourth one is P of x equals x plus 1 into x minus 2, and values of x are minus 1 and 2. So let me substitute this. P of minus 1 equals minus 1 plus 1 into minus 1 minus 2. So minus 1 plus 1 becomes 0. So 0 into minus 3, this is equal to 0. So x is equal to minus 1, this is a zero of the polynomial. So minus 1 is a zero of the polynomial. Now let's look at x is equal to 2. So P of 2 equals 2 plus 1 into 2 minus 2. So 2 minus 2 is 0. So this becomes 3 into 0, which is equal to 0. So both of these are zeros of the polynomial. So let's now go to the next one. So the next one is P of x equals x squared, x is equal to 0. So this is a pretty simple one. So P of 0 is equal to 0 squared, which is equal to 0. Therefore 0 is a zero of the polynomial. Yes, so this is yes. The next one, P of x equals Lx plus m and x is equal to minus m by L. So just put the value of x, so it is P of minus m by L equals L into, instead of x I just have to substitute this minus m by L plus m. So the L and the L cancels, you get minus m plus m, which is equal to 0. So therefore x is equal to minus m by L is a 0 of this polynomial. So the next one, let's go on to the next one. P of x equals 3x squared minus 1. So the values of x given are minus 1 by root 3 and the second one is 2 by root 3. So P of, instead of x, minus 1 by root 3 is equal to 3 into minus 1 by root 3 whole squared minus 1. So this is 3 into, when you square this, the minus becomes plus and 1 by root 3 whole squared becomes 1 by 3 minus 1. So the 3 and the 3 cancels and I get 1 minus 1, which is equal to 0. Therefore x is equal to minus 1 by root 3. This is a 0 of the polynomial. So the next part, so P of minus plus 2 by root 3, this will be equal to, substituting it in the same polynomial, 3 into 2 by root 3 whole squared minus 1. So this is 3 into 2 square is 4, root 3 square is 3 minus 1. The 3 cancels, 4 minus 1, which is equal to 3. So this, when x is equal to 2 by root 3, we are getting the value of the polynomial as 3. Since it is not 0, therefore this particular value is not a 0 of the polynomial. So 2 by root 3 is not a 0 of the polynomial. Okay, so next, the next one is P of x equals 2x plus 1, where x is equal to half. Now we have to check for this value. So let's substitute P of half equals 2 into 1 by 2 plus 1. The 2 cancels, but you get 1 plus 1, which is equal to 2. We need to have got a 0 if this was a 0 of the polynomial. So x is equal to half is not a 0 of this polynomial. Now let's go to the next section of questions. Right, find the 0 of the polynomial in each of the following cases. So the polynomial has been given and we are being asked to find the 0. So P of x is equal to x plus 5. So the way to do this is, so for a particular value of x, we are going to, when we get that value and we put it, the whole thing is going to become 0. So what would that become? So P of x would be 0 for some value of x. So let's write it as x plus 5 equals 0. So x is equal to minus 5. So the 0 of this polynomial is minus 5. So what we need to do is just equate the polynomial to 0 and find the value of x. So the next one is P of x is equal to x minus 5. X minus 5. So now what do we do? As we said, P of x should become 0. So x minus 5 equals 0. So x is equal to 5. So the 0 of this polynomial is 5. Now the next question. Next question is P of x is equal to 2x plus 5. So now the same method, I can say 2x plus 5 equals 0. So 2x equals minus 5 and x equals minus 5 by 2. So the 0 of this polynomial is minus 5 by 2. Let's go on to the next one. So P of x must be very easy now. So you just have to equate it to 0 and do the rest. So P of x is equal to 3x minus 2. So I can write it as 3x minus 2 equals 0, and so 3x equals 2 and x is equal to 2 by 3. So the 0 of this particular polynomial is 2 by 3. Now next one. Minus 2. The fifth one is P of x is equal to 3x. So what does it mean? It means 3x is equal to 0. So what does it mean? X is equal to 0 by 3, which means x is equal to 0. So the 0 of this polynomial is 0. So because when I substitute instead of x, if I put 0, 3 into 0, I'll get 0. The whole polynomial becomes 0. So the next one. P of x is equal to ax, where a is not equal to 0. So it's the same thing. So you write ax is equal to 0, x is equal to 0 by a is not equal to 0, therefore x is equal to 0. 0 by any number is 0. So the answer for this too is 0. Now the last one in this particular exercise. So P of x is equal to cx plus d. C is not equal to 0 and c and d are real numbers. So the same method, cx plus d equals 0, cx equals minus d, x is equal to minus d by c. So the 0 of this polynomial is minus d by c. You can see in that when if I were to substitute instead of x minus d by c, c into minus d by c, the c and the c would cancel. I would get minus d plus d, the whole thing becomes 0. So this is the way you should do problems where the zeros of the polynomial are asked. So another term that may be used instead of zeros is roots of the polynomial. The roots of the polynomial and the zeros of the polynomial are the same. So I hope in this session you have understood how to find the roots of the polynomial and also to check if a particular value is a zero of the polynomial. Thank you.